Hi all, my name is Saurabh and today's video we are going to look about the Windows function in Spark SQL as well as Spark data frame. In Windows section we are particularly going to look about the ranking functions and the aggregate functions which we use in Spark. So what is the windowing function? So windowing function is its name suggests that is window in the wall. So window is a small part of the wall. So if you consider a large data set and you want to do some ranking or the analytical operations on the small data set of that particular large data set, which we can divide in a particular sections, that will be a part of windowing. Multiple type of windowing functions are there in Spark, but basically in today's video we are going to see the ranking functions. In ranking functions we have rank, dense rank, row number, percent rank, and entile. uh, so we are going to look about the rank, dense rank, and row number. Percentage rank is give you the percentage of that particular row, and entile is for the percentile. So if required we can make another video for the percent rank and entile. And in aggregation functions, there are a lot of aggregation functions present in Spark, but we are going to look about the sum, average, min, max, which are majorly we are going to use in our day-to-day work. So we can see the some of the example for the windowing functions in ranking and the aggregation functions. So let me start the Spark session, and after that importing the functions and the types which we need to define a schema. And here is the main part. Whenever we want to try to use this window function, we need to import the window module from the PySpark SQL.window, and then we are taking a employee data set to understand the basic concept of the window functions in the aggregation and ranking wise. So I defined the schema for that employee data set. I will put the link in description to access the data set and the schema also, so that you can do basic operations. So in the employee data set, we have employee ID, first name, last name, email, phone number, hire date, job ID, which is the department ID, salary, commission PCT, manager ID, and the department ID number. And here we will see that how this data set we can perform the basic ranking function, which is the rank, dense rank, the row number, and the aggregation function like average, sum, min, max, etc. I will put the whole list of aggregation function and window function in the description so you can look, and also the Spark documentation for the same. So let me import these modules or the functions, and then I will define the schema, which is the StructType and the StructField. Based upon the value present, I define the integer, float, or string type. And then I will read the data set, which is the employee data set, which is present in HRDB, and this data set is tab separated, and I'm using the schema as a employee schema here. And down the data set has been read, so I am creating a temporary table which we will use when we use the Spark SQL, as well as getting the sum of the relevant fields from the our employee large data set. So in the employee table, I only selected employee ID, first name, last name, job ID, and salary. So rest of the columns are not useful to demonstrate the functions, ranking function and windowing functions. So let me get it, and if I print the schema, so salary is type float, and other things apart from employee ID is the string type, because we define the salary as a float type. So next thing, that in windowing function we need to define the windowing spec. So this spec you can define beforehand or while using the windowing function. At that time also you can use. So I defined the specs. So main thing is it will start with window, which we imported from spark.sql.window, and then the partition by is the column of the section where we want to work on. Suppose in the job ID we have 10 number of department, one have HR department, we have IT department, we have finance department. So in that case we want to apply that particular rank function to that particular department. Suppose we want top 3 from each department, or only top 3 from the HR department or finance department. We need to define the partition by, that means which column we want to do the those function utilize. We want to do any ranking, we need order, so it will be a order by clause, and by default it is ascending. If you are not defining anything, it will be ascending only, but if you want to specify it, you need to put as a descending DSC. And then we need to see that what are the functions we can define and what is the difference between the rank, dense rank, and row number. So let me first I have the employee one data set which have only employee ID, first name, last name. Let me show you the whole data set whatever we have here. So we have lot of column here, right? So if you see employee ID, first name, last name, and some of the column are null itself because we defined that null is true. So some of the columns having null value also, and the ID is having numeric values. Okay, and here we only took the uh, some of the columns in the employee data set. So for, let me just do it. Okay, now I want the only the column which is having rank uh, less than 5, and will work like it will give you that spec. Based upon spec column it will define you the ranks 1 2 3. So I will run this query. The ranking function, what it will do, it will give you the rank based upon the window spec. So we need to use with column because it will create a new column with the rank which will define as a RK, and we need to use the rank function over the spec what we defined already, that means the partition by and the order by. And if we want to filter the column, suppose I want only the column only which is less than or 5 rank. So if you see here we have ranking function 1 2 3 4 and 5 for the FI underscore finance accounts. And but here if you see we have the in IT program department we have two similar salary for two people, so it gave 3 3 to both because it's a rank, and it skips the fourth because already the fourth number is having only third rank. So we do the operation on rank, it will if a lot of people having the same matching criteria, it will give you the same rank, and it will skip the lower order rank, and it will start with the next higher order after assigning the same rank. So if we don't want to skip any of the sequence in the rank function application, so we need to use the dense rank. So if we use the dense rank here and run the query, if you see, if we go to the department IT program where last time we have 3 3 and 5, now we have 3 3 but we have the 4. So this is the basic difference between the rank and the dense rank, that you have when you apply the rank function it will skip the uh, sequence when we have the similar rows present in the rank. But in the dense rank it will not skip, it will only give you the same rank with the same criteria, but it will not skip the next sequence. Next is the row number. So what row number will do, it will assign the row number to each row. It will not do anything with the rank, it will assign irrespective of the uh, row number based upon your order by clause. So the order by is a salary, take example. So I will put the here the keyword is the row number. So if we run here, if you see, it will assign the rank. Even if IT department we have till 5, it's a 1 2 3 4 5, and it is the descending order, because in the spec we only define as a descending order. So the row number will not consider the same row as the same rank. It will give you the different row number for each row. So these are the three basic difference between the rank, dense rank, and row number. And in data frame we need to use with column and the row number and rank and dense rank as a function over and the specs. And we can filter out the column, and we can take a, suppose you want only the latest from each department, so you can just put the rank 1. It will give you the latest for the each department. There is many useful application with the rank functions, and it is very effective, because when some of the uh, functionality we can achieve through order by, but in order by we need to put all the columns which we put in the select drop apart from the aggregation column. And if we don't want all the columns, so that means we need to again do the AQ join and all those things. But in the rank we can define our partition columns and the order columns, and we can add a ranking. And if suppose we want to only remove the rank function, just we need to use the drop function. Let me show that also. So just I will remove the rank, so it will remove the rank column and it will have the desired result. So next is the using the aggregation function over the Windows specs, and how we can do it. Suppose in the same column and same data set, if we want to get the total salary for the particular department, each department, what is the total salary we are giving, so we can use the with column will create a new column and the name and the sum function with the column name and over specs, that means the partition by and the order by. So if you, I will show you the difference when we use the order by and we will not use the order by. So let me run that. So if you see here, uh, there is a incremental salary. When we define the total salary, the first one is 9,000, the second one is the 9,000 plus 8,200, and then we have the 7,800. So it is the incremental. So this is happening because we gave the order by, and because of that it is doing one by one sum. And if you see, the last is 3960, right? So if you suppose in the spec, window spec, I will just remove this order by, and I will only put the partition by, take example. Okay, so I will remove this and I will run it again, and then I will use the spec, same spec. And if you see here, now it is giving you the all, because I didn't use only order by, only I use partition by. So for the each job ID partition, it is giving the total salary count. So similarly we can use the average and the max and min, everything, whatever uh, aggregation function with the over spec, which is window, the particular section. So if you want to see the salary, like each employee salary or what the percentage they are getting, you can use that this total salary and divide by the uh, what is the salary that particular person is having, so you will can get the percentage. And uh, aggregation operation you can also perform similar to, and this is the data frame. We use the employee one data frame and we added the column total salary, average salary, max salary. And if you want to remove it, you can just use the drop column, and the operation will be performed. So next we will see that how these function which we seen above uh, can be used in the Spark SQL. So all the ranking function and aggregation functions like dense rank, rank, row number, and sum, average, min, max, we used in the data frame operation. Now we will see that how we can use same thing in the Spark SQL. So in Spark SQL, we no need to define the Windows spec. We can directly give inside the query itself and it will work. So let me create a temporary view for the employee one table where we have the number of selected columns. So let me create the temporary view and we can see that what is the employee one having. So Spark. So we have employee ID, first name, last name, job ID, and the salary. So we are going to use the same functions here also. And here we will see that how we are going to define the nested query, because in Spark SQL, when you want to apply the rank function and we want to filter out the some particular data based upon the rank function, we need to define a nested query where we need to put the rank function and then we can filter out the data based upon the ranks present in that. So there is two way that you can create two different, first create a data frame with the inner query and then perform operation on the second data frame, or you can create a nested query itself and define the in the inner query you can define the row number function, and that function you can use the in outer query. So suppose we have this query where we have select star and we selected first name, last name, job ID, and salary, and the rank function where we do the partition by. So where in the window specs we define the partition by and the order by column. So here we need to define the same thing over clause partition by job ID and the order by the salary. And suppose here I put the descending, I want no, only descending, and I gave the alias name as RK for the employee and suppose table as E. So we define E and then we want only the rank less than 5. So if we go here and I will run this, so a same result we will get here. If you see here we have 1 2 3 4 and we have the same thing 3 3 and the 5 for the row, and similar thing if we put the dense rank here, it will give you the result with the dense rank functionality. It will not skip any sequence, it will only give you after 3 3 it will give you the 4. And if I want the row number in the Spark SQL, just I need to put the row number function here. So row number will do the same thing. That means it will give assign the row based upon your partition column, and order by column it will give you the order of that particular column. Because I select descending, if I didn't select the descending, it will give you by default in the ascending order. Okay. So next we will see how the aggregation function will work on the Spark SQL. So aggregation function will not have any you can say the window spec present, but just actually I want to cover the aggregation function in Spark SQL and want to uh, give you how the query functions in SQL, which is different from the other like Oracle or JDBC, how the query functions here. So if you see, so this is the typical execution flow for any query. First it will perform the from, then where and join. It will shuffle that, sometime where will execute first and then join, or the vice versa, that is depend upon your execution engine. Then it will have the group by with, if you have having clause then it will having clause, then the select, and then the order by. So if suppose for the uh, aggregation function, if you see we define the aliases, and because the select is going from the from after form join where and group by, so if you give that alias number in where, so it will not work, it will give error, because that till that time the select operation is not performed So the only thing which select will work with the order by. That means if you have alias and you want to do the order by with that alias with the rank or the any aggregation function, sum, min, max, average, only thing you can give with the order by. But in Spark SQL, there is a difference. We can give that alias, aggregated alias function or the alias name in having also. That means this having will always come after the select. That means select will happen first. That means alias has been defined inside the uh, uh, your execution. Then we will have the having also. So let's see the example. So here I selected the first last name and then I put the sum of the salary as a total salary department from the employee one, group by first last name and having total salary department. That means the sum of that is greater than 1200. If some other platform you are using this query, it will error out because we are using the alias aggregation alias to the having clause, and which I show you the uh, order of the execution of the query, because the till now the select is not performed, it will say that we are not able to find. Similar thing if suppose instead of having, if I put in where, suppose if we are running this query where I gave the alias the sum of the salary with the where clause that total department salary is greater than 12,000, it is showing that cannot resolve the total salary department because the select clause is still not happen. First it will go the where clause and then it will try to from clause, then join, then where, and then it will go to select. So still that column is not defined, so it is not able to resolve that query. But in Spark, if we run that same with have Spark SQL having is after the select, so it will showing that if we that departments we can use greater than 12,000. So if you see, it is showing the departments whose having total salary is greater than 12,000. So if I put suppose the same is like greater than 1,000, it will show you all the department whose salary is greater than 8,000. So this is the way we can define the windowing functions. We can define the windowing specs and we can use the windowing specs, and it is very useful to use the windowing ranking functions instead of group by or some aggregation function with the windowing specs, because it is quite fast. So that's it for this video. Please let me know your comment if you want any more things on the ranking and the windowing function and the aggregation functions. And if you like the video, please share, subscribe, and comment on the same. Thank you very much. Bye.